So right now you're just changing a bushing.
Yeah, it's called a split bushing. That way you can put like we use a standard 7/8 collet in the back, and then all of our split bushings, no matter what size, they range, you know, from 60,000 to 700,000. And we can just use that standard collet in the back, and then we put split bushings for different sizes as it comes up different parts. Depending on the length of your part, you know, you might have to hold it at 3 inches while it's milling back here at the back. Generally when we cut off, we're close.
And now we're going to be running what's next? It's going to
It's just going to turn the whole shaft diameter. Eventually, once it'll turn to a certain point, it'll cue a dollar line to come back. Once the part's sticking out so far, then the sub spindle comes up. You can clamp onto it and hold it. Makes it more rigid so that it can turn the shaft. You know, you get into 6, 7, 8, 9 inch long shaft. You want the sub holding onto it when it gets out there so far.
Tell you the truth, I can't know if that makes it any worse.
Maybe I just need to be all mostly on this side. I don't know.
That's putting a groove in it, right?
Yep. Come back in and turn it a little bit more. Nothing's milling it. Just come in with 225 if you're milling that flat.
Just step milling it again?
Yeah. This will be another Y move that's milling in. It hits its standard position at X, and then it'll just mill. The width of the tool is enough that it just can go up and down in Y and back off.
Now it's doing.
It's turning the rest of it. The 437 diameter. It kind of puts like a rough taper here. Gets away most of the material, and then when it picks off in the back, then the back work comes in, faces the back, and it does the rest of this up to this 750.
And that's it. That just finished it, right?
Pretty close. It's ready to change the bushings and come up onto the 437 and pick it off.
So we're still in the cycle?
Yeah, it's sitting on an M126 right now, which is a code that basically just gives you a chance to get into your machine, shows you your green lights flashing, gives you a chance to get into your machine, unlocks your door locks, you can go in and change your bushing or what have you. Basically a pause in the program.
Right.
Yeah, it's just a pause in the program. Basically what holds those in is they're undercut and there's just a little rubber O-ring. Keeps it in there when it fires the spindles both up so it don't chuck it out.
Yep.
Because what it'll do is it'll come up to a certain position, it'll be in the sub, it'll sync up, and then they both grab at the same time. Keeps your bushing from spinning on you.
And now what is it doing this time?
Now it's coming up, and it's going to clamp up, it'll sync up, start spinning, and then it comes up with your cutoff, and it does the cuts the part off so it can go back to your sub working. Here's where I was telling you where it'll start working on both front and back. Saves you a little bit of time. It can get a little bit of the front work done while it's doing this. Otherwise, like say you had a tool right now, say it turned just a little bit, $1 come out, if $2 was the need to work, it keeps the front from having to wait, because like a tool, you know, a tool from the top turret would be down there working. This way it eliminates and gets the turn dimension out of the way, and then it can come over and start working with $2.
It's finishing the one part while it's starting the other at the same time.
Yeah. It's finishing this one over here.
Yeah.
Finishing,
creating the overall length
while it's starting this one.
to turn the front on the other one. And see what I was saying now, even though it's turned as much as it needs to for that to come in and start doing that, milling that front part work, this will have to wait. But what I was saying earlier about the sub working, if it was just sitting back here, then you just have twice as much to wait in the front. It's a time thing. Generally, you just have a few tools that work in the back, and you hit the 712, and she'll jump back up and start running on $2 again. So now back to where you were at, where it was milling. Yeah, right. And you know, it all depends on how your engineer programs your parts. Sometimes he will stop it before that mill comes down so you can get that out, or you know, it just depends on how they want to do it. And in the same token, you can run in single cycle to where it wouldn't do any of the front work while the back work was working. The back work gets done, then the machine would just set. You pull your part out, then you start again.
It's all a programming.
Yeah, it's all programming. Yeah, how they want to program it. Because obviously, if you're just running your first part, you don't want to run in continuous because you got to check your part to make sure your next one's going to be good. So you run in single mode.
Somebody told me yesterday that we're moving it in for a week and a half.
I don't know, I told me this weekend we're supposed to get something Saturday. Oh, I was sitting here thinking about, remember how George had that thing tied around the front of his boat and it'd come up over and it'd come over that pole, hold that pole for flexing. Do that with a big rope on mine to hold my tarp up. Tied it off the motor and it was loud. You know, comes across the front windshield. Now that it's ripped.
Thank you.
Now if you're running a small part, say you have a part that's maybe about a ½ inch long, it has an option where you can use a knocker, it's called a knockout. And it's set up back here to put a certain code in the program, and if the part's done here, this arm will come up, the knockout will hit the part, knock it out. Generally we use brass ends. It'll knock the part out in the basket swings down, drops it into here, and then you can open your door and get your part out. Then you don't ever have to have the M126. It'll just keep continuously running. Get into a longer shaft like this, you don't want to be pushing it out because you got the chance of it getting sideways and locking up or jamming or something.
And this right now is working on the Y-axis?
It is, yeah.
It's hard to see it moving, but it's definitely creating that
so
notch.
Yeah, it's so small, if it's moving at all, it's just because it's putting a 30,000th radius at the back side of where the mill meets that shoulder. It's probably be better to, on the other mill to see it actually moving in the Y. It moves a lot further in the distance. Yeah, when it runs this mill here at the end of the shaft, it does more of a, you can actually see
The head moving.
the turret.
Turret.
Too.
And what do you guys? What's the steel in here you're running right now?
17-quart.
Stainless.
Stainless, aluminum, titanium, plastic.
Well, actually, I take that back. My last job was that. This is actually S455, a harder steel. Still stainless.
Okay.
I think it's a non-magnetic though.
Okay, let's go back over to the scroll. And you'll see that it's still cutting.
That just moved into there. Now it's cut. Now it's moving into Y again. Backed up and moved over to cut it white. The Y must have backed up and moved over to cut it white.
And now
Now it's set and changing
it's asking us to change again, right?
So I think
That's
now
it.
it's went through the whole cycle. Yeah.
Yep. On its hydrobar feeder. Here's it going in.
Sometimes when you got a parameter at 8, it's here. If you move doors when it's in its middle of its cycle,